Hey everyone, this is K2 Concept YouTube channel and I'm Dave Kome by name. Now we'll be solving two problems on how to use the chain rule to differentiate. And that's the first problem, y equals to ln sine x squared plus 2x plus 1 raised to the power of 3. Now if you look at this problem very well, this is a problem we cannot differentiate easily, and it's not even on our table of standard derivative. So in order to differentiate this, then we need to apply the rule known as the chain rule. The chain rule, which is also known as the composite function or the function of the function. Now to do this, we will try to reduce the problem by introducing variables. Now we say the first thing, let u equals to sine x squared plus 2x plus 1. And also, if we do this, the main question here, which is this bracket here, has been replaced with u. So your y now becomes ln, instead of this bracket now, u raised to the power 3. Now, we cannot differentiate this also because it's not in our table of standard derivative. So what we do is, we still go further by introducing another variable to reduce this u cube. So also we will let t equals to u cube. So equation 2 now reduced to y equals to ln t, which we can easily solve now because ln t is in our table of standard derivative, which is something as ln x. So if I differentiate ln t, I will have dy dt, which is 1 over t, because ln x is 1 over x, ln t is 1 over t, ln b is 1 over b. Now differentiating equation 3, which is your normal way of differentiating power function. The power will come down and multiply the original function, then you subtract 1 from the power. That's what we have here. So 3 minus 1 is 2. Now lastly, differentiating u with respect to x. These are the three functions we were able to get when we replace them with two variables. Then we have u equals to sine x squared plus 2x plus 1. Now, sine x squared is not the same thing as cos x squared. Is wrong, because on our table of standard derivatives, only sine x we have there, which is cos x. Now to do this is what we call a chain rule problem also. But I cannot apply chain rule by replacing it to a variable because the problem inside the main problem. So what we'll do to achieve this is just to differentiate our x squared. We get 2x because there are two functions. Then differentiate your sine, you have cos. Cos cannot stand on its own. So this x squared, which is a power function, will return back to support it. So 2x differentiated becomes what? 2. Then combining the 3 together, we get dy dx. So dy dx equals to dy dt times the t du times du dx. What is dy dt? Dy dt is 1 over t from what we got here. Then the t du is 3u squared. Then du dx is what we have here. So if you combine the 3, you get that as your dy dx. Now we'll continue. We'll replace. Don't forget, our t originally, our t was u cube from our question. If we go back to the question, so we'll replace with u cube, then 3u squared equals to this. So applying indices on these 2u, we have u. So 3 times this, we have this. Then this is over 1. Don't forget, this is over 1. Then u times 1 is u. So if you have this, you replace your u back, you have sine x squared plus 2x plus 1. Now dy dx, if you open this bracket, this is your dy dx. Now that's the first question. Now let's go to the second question, which is similar to the first but in a different form. They said y equals to cube root of ln x squared minus 2x raised to the power 5. Solution. Now in order to solve this problem, we need to apply a common law we know, which is the law of indices. Now that law of indices, please, in differentiation, law of indices is more essential, or is very essential, because there are some problems you cannot differentiate easily. First, you have to apply the law of indices to those questions first before you can solve them. Similarly, this question is one of those questions, and this is the law. It said n root of x is same as x raised to the power 1 over n. Nth root of x all raised to the power m will give us this. Then applying the law of indices, what we did here, we have this cube root going outside to become 1 over 3. Then 5 multiplying this one becomes 5 over 3. Then doing the same thing we did in the first question, let u equals to x squared minus 2x. Similarly, this bracket. Then y equals to ln u raised to power 5 over 3. Now we can not differentiate 2. So we have to introduce another variable to reduce these 2. So we say let t equal to what is here so that we can differentiate easily. So t equals to u raised to power 5 over 3. Now, if we do that, equation 2, which we could not differentiate as earlier stated, now can now be differentiated because y is now equals to ln t, which is in our table of standard derivative. If I differentiate ln t, I will have 1 over t. We did that in the first example. Now differentiating t with respect to u also is normal way of differentiating your power function. 5 over 3 comes down, then subtract 1 from the power. We have something like this. 5 over 3 minus 1 is 2 over 3. Now differentiating u with respect to x, that is the first one here. You have 2 comes down, becomes 2x. Then differentiate 2x, your answer is what here? 2. Now combining this result we got together, we have our dy dx. So our dy dx equals to dy dt times the t du times the u dx equals to 1 over t times 5 over 3 u raised to power 2 over 3 times 2x minus 2. Now replacing t, because t was not originally in the question, we have t to be u 5 raised to power 3 times 5 over 3 u 2 raised to power 3 2x minus 2. Then collecting like terms, u and u can stay together. Then applying indices on this u. We're told in law of indices, second law, that if two things are multiplying each other and they're having the same base, we should take one and add the power. The second law said if they are dividing each other, we should take one and subtract the power. And this falls under the second law. That's the division law. Then if I do that, we have minus 3 over 3. Then the answer becomes minus 1. This is also a law in indices, which is what we call negative law. And that's what you are seeing here. So if I apply that law, it becomes 1 over u, 2x minus 2. So 5 over 3 times 1 over our u also was not the original question, which is x. So we have to return it back to the question by replacing u with x squared minus 2x. So if you do that, 5 times 1 times this, we get this. Then 3 times this, we get this. If you multiply, you have this as your final answer. Once again, this is K2 Concept YouTube channel. Do not forget to like, subscribe, and comment. And lastly, share to your friends so that they can also be part of this knowledge. Thank you for watching. See you in our next video.